Hello all, welcome to our new session on Zero Trust Security Model and Architecture. In this session, we will discuss about Zero Trust Security Model, Zero Trust Security Architecture, the concept of Zero Trust, what are the three key elements of a Zero Trust architecture, what are the principles for successful implementation, and we'll also discuss a sample Zero Trust architecture. Let's get started. A Zero Trust architecture enables organizations to prioritize access and restrictions. The goal is to implement a Zero Trust policy across all traffic, to ensure no user, device, or system can put the network at risk. Zero Trust architectures typically enforce three main principles, that are, there is no such thing as trustworthy users, multi-factor authentication is a must, and microsegmentation is critical for enforcing restrictions. To implement Zero Trust security, organizations need to adopt information security practices and tools that expand their endpoint visibility and enable control over access and privileges. Zero Trust architectures are constructed on the basis that there is no secure perimeter. Instead, every event and connection is considered untrusted and potentially malicious. The goal of Zero Trust architectures is to keep networks protected despite increasingly sophisticated threats and complex perimeters. This is why Zero Trust architecture is also called Zero Trust Network, or in general, Zero Trust Security. But, let's take a step back and talk about what do we mean by Zero Trust? A Zero Trust model implements data security that prioritizes access and restrictions. This is particularly relevant in today's business environment, as organizations increasingly need to secure a remote workforce. In a Zero Trust architecture, users, devices, and services receive the least possible privileges until proven trustworthy. In a few cases, when implementing Zero Trust network access, privilege restrictions extend even after authentication and authorization. Zero-threat architectures are designed to reduce the vulnerabilities associated with cloud resources, ephemeral endpoints, dynamic attacks, and IoT devices. These architectures are often adopted by organizations with highly sensitive data and systems. Now let's discuss the key elements of a Zero Trust architecture. When evaluating a Zero Trust architecture, there are three elements that should be considered. These elements are vital to the successful deployment and construction of Zero Trust architectures. First element is, no false sense of security. In traditional architectures, anything that happens inside the perimeter of a network is considered trusted. The assumption being that any users or activity in the network has already passed authentication and is authorized to be there. This model assumes that perimeter security is flawless and that insiders are never malicious. To anyone familiar with security, the flaws in this model should be obvious. There are many situations in which users and events inside your perimeter are not to be trusted. For example, an attacker who has entered with compromised credentials or insider threats, which may abuse privileges or move laterally through the network. A Zero Trust architecture makes this understanding explicit, and prioritizes protection against insider threats. The second element is multi-factor authentication. Multi-factor authentication is the use of credentials in combination with an additional authenticator. For example, requiring a user to scan their fingerprint, or confirm a PIN sent to a mobile device. It significantly reduces the chance that attackers are able to use compromised credentials to access your systems and data. A Zero Trust architecture implements multi-factor authentication as a double check against its own security measures. It uses multi-factor authentication to ensure that users are who they claim to be, and ensures that access and transactions are allowed correctly. Multi-factor authentication also plays a large role in PCI security, which helps organizations protect credit card data in accordance with the PCI standard. The third and last element is microsegmentation. Microsegmentation is the use of access controls to isolate the various components and services in your system. It allows you to layer security measures, such as firewalls or authorization measures, for greater security. It also lets you restrict access to assets on a granular level, reducing the chance of an attacker taking advantage of lateral weaknesses. A Zero Trust architecture leverages microsegmentation to ensure that even users or applications inside a network are properly restricted. It ensures that even if an attacker does enter the network, the amount of damage they can cause is severely limited. Microsegmentation and cloud-native development often go hand in hand. However, microsegmentation by itself does not cover all of your cloud security needs. It's important to make the distinction between microsegmentation as a security measure and cloud security as a whole. Moving on. Let's discuss principles for successful implementation of a zero-trust architecture. When building a zero-trust architecture, there are several best practices you can employ. Below are 4 practices to help you prioritize your efforts, securely validate devices, ensure visibility of your systems, and eliminate false trust. First, know your architecture including users, devices, and services. To secure your network and assets, create a full inventory of your users, devices, and services. This includes what data and assets each need to be accessed, what possible liabilities that access creates, and how access is managed. In particular, focus on those assets and components that are connected to your network. For example, prioritizing focus on servers with internally or externally facing endpoints over tape backups. It is also important to pay attention to pre-existing configurations and permissions. If you are transitioning from a traditional network model to zero trust, you may need to update services and assets to ensure continued functionality. Second, create a strong device identity. To ensure that only trusted devices are allowed on your network, start by establishing a unique, traceable identity for each. These identities allow you to verify that assets are managed efficiently and to expose untrusted devices. Additionally, the identities you create for devices are necessary to authenticate permissions and access according to the policies you define. There are several ways to identify devices, depending on the device's hardware, platform, and type. The most reliable method is to store identity information on secure hardware coprocessors. This is very difficult to fake and is a high-trust method. When hardware storage isn't possible, you can use software-based key stores. This method provides a reasonable amount of confidence for well-managed devices. However, it can only give low confidence for poorly managed or unmanaged devices. Next, we need to focus our monitoring on devices and services. Comprehensive and continuous monitoring helps ensure that even if your security measures fail, you are able to detect and stop attacks. In particular, focus on monitoring how devices and services are interacting. For example, what is being requested, what processes are performed, and what data is accessed. When monitoring, keep in mind that each device needs to be evaluated individually. This does not mean that you should not correlate data across your devices. It does, however, mean that you can't rely on traffic choke points to catch suspicious events. Rather, evaluate device data in context of the events occurring on your network to ensure that the traffic matches your defined security policies. Lastly, don't trust the network, including the local network. Remember that zero trust means zero. This includes your local network. You should not be relying on your network itself to protect communications. Instead, build trust into the devices and services operating within your network. For example, by enforcing encryption protocols such as TLS. If you rely on local networks to be secure, you are potentially opening your connections to attacks such as DNS spoofing, man-in-the-middle attacks, or unsolicited inbound connections. Now let's go through a sample zero-trust architecture. You can see a zero-trust architecture on the slide. It uses various security policies to verify identities and devices, which are requesting access. It also used threat intelligence sources to identify any sort of threat or negative event that might occur during access and authentication. Hope the content was useful. Please subscribe to our channel to stay on top of all upcoming videos. Thank you.